Hi everyone, today we'll be talking about GPU programming. So first, how can we program GPU? It is using CUDA, which is a parallel computing platform and programming model invented by NVIDIA. Some of the applications of GPU programming are usually processors that require high computing power, and these examples include medical researchers using GPU programming to identify hidden arterial plaque without invasive imaging techniques or exploratory surgery. NASA also uses GPU's computational power to run simulation models to keep air traffic smooth. However, there are many limitations that are hampering the widespread adoption of GPU programming. There are two key conditions that a process must meet for running on GPU to be faster than on a traditional CPU. Firstly, it has to be computational intensive. That means that the time spent on computation significantly exceeds the time spent on transferring data to and from GPU memory. Nextly, the computations must be able to be broken down into many small independent units of work. Other limitations include the unique infrastructure of GPU unlike general-purpose processors such as all the Intel cores that everyone is familiar with. And due to its unique structure, programming has to be done separately, which leads to extensive change in the source code in order to utilize GPU. Now I'll pass on my time to Yechun, who will go through a short demo with you.
Hello, I'm Yechun, and I will be do a small demo about GPU programming today. First, I will start with the drivers, since my computer is using NVIDIA GeForce, and you have to first download the NVIDIA driver for the GPU, and just download it. After downloading it, just install it. It will make you do some updates and just update it. And then the second thing, you have to download the CUDA toolkit. It is also the NVIDIA developer thing. And you have to download it. It is 8.0. It is quite big, 1.2G. It takes you quite a lot of time to install the toolkit. You have to download it because this tool is the prerequisite for you to start a GPU programming. And the third thing is, I have found a library called JCUDA. Because the CUDA toolkit archive, as shown on the mouse, it is actually programmed and mostly manipulated in C# and C++. And therefore, since we are learning in Java as in SMU, and therefore, I have found this library. It is called JCUDA, and its function is to make us able to manipulate the CUDA toolkit in Java. You have to get and download it here. You install the link here. And then inside it provides a Git repository for this. It's just whole new files you can download as well. And after downloading, it will be something like sorry, I'll show you later. Okay. It will become something like this. Okay, it will become something like this. Basically, you can see all the libraries here, and you can see all the Git files here. Yeah, it's just basically placed there. It is a red mark because I have changed something inside, and that's why it's a red mark. Okay, and then I'm using NetBeans as a way to manipulate it, to code it, yes. And it is basically a Maven project. It's all Maven projects. I've loaded all of them inside. Well, JQDA main, it's the, how to say, mainframe, or it's a main for all these. And inside the main, you can see all this. It is all loaded already, and yeah. And then now I'll run a few test cases about it. And these are test cases I found on JQDA as well. And it's basically here, test packages, and these packages are basically for you to test about whether your GPU, how your GPU is working, and what is it working and how's it working. And basically it's a simple test, basically for the what's that called? That's basically for the interesting curiosity, because this is quite basic. I'll run a few test methods and see. Okay, on this I will build. Oh, sorry, my computer is quite slow. And there are some small errors just now, and it is quite solved because it's basically about the library problem just now, and I have added inside. And basically the testing is just to show whether it works. It is working fluently, and it's a bit failure just now. Now it is okay. And then this is basically the end of our presentation, our demo. I've showed you where the components to download and the possible libraries to use as a Java, and I hope that helps. Thank you, and have a nice day.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over. Thank you.
Thank you.